So, picking up where we just left off, we just talked about direct substitution. If you can, plug that number in, that number that x is approaching to your function. If you get a real number solution or a real number answer, you're done. So, it can't just be that easy, right? And that is why we have to answer the question. In fact, pretty much the rest of how we find limits is a response to this question. But what if direct substitution leaves me with a 0 in the denominator? Okay, so I try to plug it in and it doesn't work. So the first thing we have to talk about is there is a big difference between getting two different possible solutions. So you can get a number over 0, b over 0, where b is not 0. That is one option. And the other option is you could end up getting 0 over 0. And these are very different. And so it's really important that we start now by looking at what's different about them. Okay, so we're going to start by looking at b over 0. So you get a number over 0. Maybe it's 5 over 0 or negative 17 over 0, something like that when you do direct substitution. So in this case, what we're saying is the numerator is a number, but the denominator is approaching 0. And so what that means is you're going to end up with an infinite limit or a vertical asymptote at this place. Okay, so the limit does not exist and is unbounded. So it's equal either positive, whoops, that wasn't what I was looking for. It's either positive infinity or negative infinity. Okay. So these limits don't exist. We know that. And we also know that the way they don't exist is that they are infinite. So how do you figure out which one it is? Is it positive infinity or negative infinity? Well, you could look at the graph. If you had a graphing calculator or you knew what that graph looked like, you could look at the graph to kind of determine, is it going up or down in the area that I'm looking at? Or you can also pick an x value close to that number that you're approaching, or you need one on either side if it's a two-sided limit. And you just look to see, is it a big positive or is it a small negative, right? So for example, let's say we were trying to find the limit as x approaches 4. And we have this function here, x minus 3 over the square root of x plus 5 minus 3. So if I go into direct substitution, I would have one over 0. Okay, so here is that situation. It's a number over 0. So I know this is going to be an infinite limit. The question is it going to positive infinity or negative infinity? This is a two-sided limit. So I am needing to look at both sides of 4. And again, there's a couple ways to do that. You could start by plugging in like a 4.1 or a 3.9 to try to see what kind of numbers you're getting out. The other option is to graph it. So I'm going to go ahead and just open up Desmos, which I have already graphed. Let's see here. There we are. So you can see my function is graphed. And well, it looks like I definitely have an asymptote there. Here's my x equals 4. And it appears that as I approach 4 from the left side, it's going to negative infinity. But as I approach 4 from the right side, it's going to positive infinity. In which case, if I were to just, again, it's always a good idea to justify your answer. So I don't have to have a beautiful picture. But I did see the function doing something like this. So because it doesn't go to the same type of infinity on either side, I can't actually write that this equals infinity or negative infinity. So I'll just write dne, but you'll notice I included the picture for a justification. If this had given me a 4 from the right, if there was a plus here, I could have written positive infinity. Or if it had said 4 from the left, I could have written a negative infinity. It's always a good idea to put as much information as you know in your answer. So if you can answer with an infinity symbol, then you should. Okay, so that was our first option. When we tried direct substitution and we get a number over 0, that is telling us we have an infinite limit that doesn't exist, which is very different from the option where direct sub is giving us 0 over 0. Okay. If both the numerator and the denominator are approaching 0, you do not have enough information from direct substitution to determine whether or not the limit exists. So this is what we call an indeterminate form. And what that means is you don't know anything. You cannot make a conclusion. The limit may exist. It may not. You have no idea. So 0 over 0 means nothing. It means you don't know anything and you have to try something else. And so we're going to get a whole bunch of other options, other strategies, things to try, and they're all going to be, you try them when you've got 0 over 0. Okay. So it's critical that you realize that if you end up with 0 over 0, you don't say, oh, that's 0, or, oh, that means it doesn't exist. Nope, it means neither of those things. Okay. It simply means you got to try something else. Okay. So for example, if I were to look at this limit as x approaches 0 of 1 minus cosine x over 2 sine squared of x, again, I'm going to try to plug in the 1 minus cosine of 0 over 2 sine squared of 0. Cosine of 0 is 1, so I have 1 minus 1 on the top. Sine of 0 is 0, so I have 2 times 0 squared on the bottom. And there it is, the elusive 0 out over 0. So at this point, we haven't talked about any of these strategies, but we just want to outline that this is indeterminate. So we must try a different strategy. So these are the ones where all the other strategies are going to be brought into play. Okay, the 0 over 0. Okay, so the rest of what we're going to be talking about is basically going to be, what do I do then if I have 0 over 0? What can I try?